Let's have problem number 2. X plus 2 all over x minus 3 is less than or equal to 0. In step 1, on the left-hand side, we have a single rational expression. On the right-hand side, we have 0. So we're done with step 1. For step 2, we equate the numerator by 0. Transposing it, we have x equals negative 2. If we substitute negative 2 to the inequality, the original one, it becomes negative 2 plus 2 all over negative 2 minus 3. Negative 2 plus 2 is 0 over negative 5. And when 0 is divided by any non-zero number, the answer is 0, which is less than or equal to 0. And this is true. Since it is true, then we need to shade negative 2 in the solution set, or we represent it using a shaded circle. For the denominator, we equate this to 0. I'm sorry, but that's not x minus 1. That should be x minus 3. Let me correct that. X minus 3, so it's x minus 3 here, equals 0. So x is equal to 3. Now, when we substitute 3 to the inequality, look at the denominator. The denominator becomes 0, so it becomes undefined. Thus, 3 is not part of a solution set. In step 3, as we draw the number line, for negative 2, it is true, so it's represented by a shaded circle. But for 3, it's false, so we just remain the circle unshaded. Next, step 4. We need to assign test values. Before negative 2, let's assign negative 3. Between negative 2 and 3, we can assign 0. So we have 0 here in our test value. You see this one? Then, after 3, we could assign 5. When we substitute it, negative 3 to our inequality, it will give 1/6, which is less than or equal to 0. And this statement is false. When we substitute 0 to the inequality, it will give us negative 2/3 is less than or equal to 0. This is true. If we substitute 5 to the original inequality, we'll have 7/2, which is less than or equal to 0, and this is false. We only consider the true remarks, and it's between negative 2 and 3. So as we shade it, this is the only true part. We write it in an interval notation. Since it is shaded, we use a bracket. Negative 2, comma, this is an unshaded part, 3 parentheses. That ends our second example.